If you dropped a lead fishing weight on Venus, it would melt before it even hit the ground. Think about that. Mercury is practically kissing the sun. Yet it's Venus, the next planet out, that's the hottest in our solar system, roasting at a mind-boggling 867 degrees Fahrenheit. That's hot enough to vaporize zinc. It seems like a paradox, right? Venus is nearly twice as far from the sun as Mercury, so it should be cooler, but it isn't. The real secret to Venus's extreme heat isn't its distance from the sun, but what's hiding above its surface. Let's start with Mercury. It has what's called an exosphere, which is basically no atmosphere at all. Because there's no insulating blanket, the planet can't hold on to any heat. When the sun hits it, temperatures can soar to 800 degrees Fahrenheit. But as soon as the sun sets, all that heat radiates straight back into space, and the surface plummets to a bone-chilling minus 290 degrees Fahrenheit. Mercury gets plenty of solar energy, but it simply can't store it. Now, let's glide over to Venus. Here, the atmosphere is a suffocating shell of carbon dioxide, 90 times denser than Earth's. This isn't just a blanket, it's a supercompressed, inescapable duvet. Sunlight manages to warm the surface, but when the planet tries to release that energy back into space as heat, the CO2 molecules absorb it and fling it right back down. This creates a runaway greenhouse effect, a heat trap of planetary proportions with absolutely no exit strategy. Scientists believe Venus once had oceans, just like Earth. But as the planet heated up, water vapor filled the atmosphere. High up, sunlight split the water molecules into hydrogen and oxygen. The light hydrogen atoms simply leaked away into space. With its oceans gone, there was nothing to absorb the carbon dioxide being pumped into the air by countless volcanoes. This created a vicious feedback loop. A hotter atmosphere held more water vapor, which trapped more heat, which made things even hotter, until the planet became an irreversible inferno. To truly feel Venus, imagine stepping inside a pizza oven set to its maximum temperature. Lead liquefies at 621 degrees Fahrenheit. Venus is over 200 degrees hotter. High above, thick clouds of sulfuric acid rain down corrosive droplets that evaporate before they ever reach the ground, creating an endless toxic cycle. The air at the surface is so thick and dense it moves like syrup. A person exposed on the surface would be simultaneously crushed, boiled, and choked. Venus and Earth started as cosmic twins, but their fates diverged. Earth is just a little farther from the sun, which allowed it to keep its liquid water. Crucially, Earth also has plate tectonics, a geological process that shoves carbon deep into the planet's mantle, preventing it from building up in our atmosphere. Earth also has a strong magnetic field that protects our atmosphere from the solar wind. Venus lost its magnetic field early on, leaving it exposed and allowing its transformation into a hellish wasteland. For decades, Venus was a mystery behind its thick clouds. The Soviet Union's Venera landers in the 1970s and 80s were tough enough to survive the surface for a short time, sending back the only color photos ever taken from the ground. More recently, we've used radar to map a world covered in volcanoes, suggesting the planet is still actively belching CO2 into its atmosphere. Future missions, like NASA's Da Vinci Plus, will drop a probe through the clouds to sniff the chemistry and find out for sure. If you're enjoying this descent into planetary madness, tap that subscribe button and ring the bell. And tell us in the comments, which death world would you rather visit? The lead bowling surface of Venus or the sulfur-spewing moon Io? Let us know. Venus is the universe's ultimate cautionary tale. It's a stark warning of what happens when you pump carbon into an atmosphere faster than a planet can handle it. Earth's atmosphere has just 0.04% CO2. Venus's is 96% CO2. That difference is what separates a garden from a furnace. Studying Venus helps scientists sharpen their predictions for Earth's own climate by testing their models under the most extreme conditions imaginable. So what's the takeaway? Distance to the sun sets the stage, but the atmosphere writes the script. Mercury is a world of extremes because it has no atmospheric blanket. Venus is a furnace because it's wrapped in a toxic duvet 90 kilometers thick, trapping heat until the ground is hot enough to melt lead. The lesson is simple. Never judge a planet by its distance from the sun, but by the atmosphere it keeps. Which world would you choose? Drop it in the comments, and don't forget to like and subscribe.